Recent text-to-image generating models have shown amazing capability to synthesize images from free-form text prompts. These advances allow us to visualize the human imaginations without the requirements of artistic skills and technical labor. But all these models use plain text as their interface. In contrast, we communicated with each other with rich text on almost every other occasion, like emails, web pages, news, and books. In this work, we aim to enable expressive text-to-image generation with rich text. For example, the font styles express specific vibe. This looks elegant. This looks playful. This looks spooky. And this is a ransom letter. Okay, let's take a look at some results with rich text. Here we generate a beautiful image with stable diffusion XL, but you may want to change the hair color. With rich text, you can do so easily by choosing a specific text color, like pink, or make it green. Font styles evoke emotions. Here, the font style creates localized artistic editing. We can also change the style of the night sky into Van Gogh's painting. Here's another example of font styles. The image looks great, but the guitar looks a little bit boring. Let's spice it up by describing various styles for the guitar. The footnote provides additional descriptions that complement original text. For example, you can use it to describe what kind of dress this Lego girl wears. Footnotes also provides an excellent way to interactively explore your visual imaginations. We can add leaf litter on the ground, change the season to winter, and write words on the signpost. Here's another example, this time indoor. We can add some candles and plants, add some colorful pillow to make the room feel more vibrant, and change the painting on the wall. Sometimes it's hard to describe exactly what you have in mind using text, but you can use a hyperlink to a reference image. This allows us to generate a scene with a specific dog. Good boy! Another example showcases changing the backpack from one single reference image. No other user edits are needed. Font size help emphasize particular words in a sentence. For example, we can piss off an Italian by adding more pineapples on the pizza, or add more pepperonis or mushrooms. We can compose any rich text together. Change the hair color and give your coffee cups a stylish design. But how does it work? Given a rich text prompt, we first extract the plain text and use it to condition a pre-trained diffusion model. The diffusion model iteratively predicts and removes the noise at each time step. This gives us a sequence of denoising outputs. Aside from the images, we also collect the feature maps, self-attention, and cross-attention maps. In particular, the cross-attention maps capture the association between image locations and the input text tokens. If we take a column and reshape it back to the size of a 2D image, we can see that they encode the spatial extent of the text token. This is helpful for localized editing. Unfortunately, the localization from cross-attention maps are not precise, thus often leads to visual artifacts. To address this, we leverage the self-attention maps. The self-attention maps encode the association for each image location to all other image locations. Using this affinity matrix, we perform spectral clustering to over-segment the image into meaningful regions. We can then use the cross-attention maps to label these results to produce cleaner spatial maps for each token. We call these token maps. Now, let's see how we can use these token maps for rich text to image generation. We represent the rich text input as a JSON file. For each selected entry, we use the same diffusion model to predict the noise. We then compute a weighted average of the predicted noise using the corresponding token maps. Removing this noise completes one denoising step. This is great, but how do we get precise color control, like a specific RGB color triplet? To do so, we apply the region-based gradient guidance using the current clean image prediction. Finally, to maintain the consistency between rich and plain text generation, we use two strategies. First, we inject the feature maps and self-attention maps from plain text generation to help preserve the structure. Second, we blend the plain text results to preserve the content of unformatted text tokens. Check out our project website. You can learn more from the paper, code, and a demo. I hope you try it out. I'm excited to see what you will make. Thanks for watching.